Hello, this is Group 1, and this is our final project presentation for database systems, where we describe and explain a database system for Ubuntu technologies. The problem statement that inspired this project was Ubuntu Technologies, a Ghanaian digital services company, currently stores its clients, products, purchase, and other sorts of data in different places, which makes retrieval of data demanded by Ubuntu clients and employees difficult. Thus, we have created a database system that deals with this problem by storing all the required data in one place for easy access.
Now, moving on to our enhanced entity relationship diagram, we have five strong tables, which are shown in blue. And then the other tables shown in purple are our weak entities associated with the strong entities that they point towards. To now, let's start with our first strong entity, which is the client entity. Now, the client entity has a relationship with the purchase entity in that a client makes multiple purchases. That's a one-to-many kind of relationship. Now, the product entity has a one-to-many relationship with a purchase entity in that one product has many purchases. Now, moving on to the dev team entity. Now, this entity has a one-to-many relationship with the product entity in that a dev team can or develops many products. Now, the product entity has a one-to-many relationship with the feedback entity in that one product can have multiple feedbacks. And then the client entity has a one-to-many relationship with the feedback entity in that one client can provide multiple feedbacks. Now, this that we have in Diamond show the relationship from one entity to another. Now let's move on to the enterprise rules represented by the AR diagram. Our main enterprise rules are, firstly, a customer can make zero or many purchases, and this is under the customer to purchase, the relationship between the customer and purchase or client and purchase entities. Now, next we have a product can be involved in zero or many purchases, and this is a rule represented in the product entity in relation, like the relationship between the product entity and the purchase entity. Now, the next enterprise rule is that each product must be categorized as either AI, IT consult, or app, IT consult or apps, but only one of this. And this is under the products entity. Remember that we under the products entity, we had our weak entities as named as AI, IT consult, or apps, and our product has to have either of the names. Now, let's move on to the next entity rule, which is each piece of feedback must be categorized as either low rating, medium rating, or high rating, but only one of this. Note that these are also the names of the weak entities under this um, entity, which is the feedback entity.
So now, right after our EAR, we have made a logical database design for each of the entities in our database. So as you can see here, this is a table of the entities. This one is the table for the client entity, the strong entity with its attributes, client ID, client's name, and all that. Its primary key is client I, which is a data type of int. And moving to another, strong entity purchases, you have its primary key being purchase ID with the client and product ID being foreign keys because they are the primary keys in the clients and products table respectively, both strong entities. So this is just a brief look into how our logical database design for each of our entities are. Okay, so now we move to the actual SQL code, the actual implementation of our design. So we have created our database in Ubuntu Customer DB here, and now from this we are moving to the data definition. So actually creating our tables with their attributes and assigned data type. So as you can see, we have the clients table with its various attributes with some, and they're all under constraints. So for example, client ID, it's the primary key of the client's table. So of course with the primary key, it can't be null and its values must be distinct for all. And for the rest of the attributes from client's name to address, they cannot be null. They cannot be null because you are dealing with actual clients information. So there's no point in storing empty clients data. And also you can also see here for the government table, which is a weak entity of clients, its client ID is actually just, sorry, its client ID being a primary key of clients. It's a foreign key in this table government. So as you can see, foreign key references client's ID. So this is just a little example of how our data definition for the tables and their attributes are. You can see that we have not made very unusual choices for assigning the appropriate data type for attributes. All of our IDs are ints, our dates. For example, you can see here feedback date in feedback table. Its data type is dates because it's a date, and the rest are all varchars. So we have not made any unusual choice. Now we move on to the data manipulation bits of the database. So just to ensure that everything works as planned, I will run it 3 times. So as you can see at the bottom, everything is showing, all the data selection is showing without any error. So I've just run it 2 more times, and as you can see, there's no error. So you can be assured that things are working as planned. So now let's begin with the first functionality out of our 7 that our database can do. This one, it retrieves and sorts by the highest frequency, the specific client or client type that will purchase a specific product. So with this one, we'll have to um, select data, rely on data from multiple tables, from feedback, clients, products, and all that. So as you can see here, after we have selected the necessary information we want, we are using the joins, select joins, to get that data from the various tables and grouping them by the required attributes to produce what we want. And the second functionality is we have to just list all the clients that have purchased products with the product's name if the client has provided feedback. So once again, we'll need to rely on data across several tables, the client's feedback and clients and products. So then, as you can see, we have selected client's name and product's name, and using joins, inner joins, so that we can put these tables together to get our desired information. C is we need to just retrieve the team, the development team that's working on each product, and sort by their team name. So that's one is pretty simple. So we just get the product name, team name. Of course, we do some joining, then we order because we want to sort by team name. So we use the order by to do that. So the fourth functionality, we just need to sort by lowest to highest cost and price of each product. So after we just select everything from products, we just order everything by cost and price, both ascending. This is what the ASC means here and for this order by statement. Now, for E, our fifth functionality, we just retrieve all purchases made and their total income. So we just need, with this one, we need to use an aggregate function. So sum for the product price, the price attributing products. Note that across the functionalities, we are just using aliases to shorten the declarations of the tables just to make it faster to read. So here we have found the sum of the price and have produced this and grouping it by the product's name. Okay, so the sixth functionality calculates the total revenue generated from purchases. Again, we use an aggregate function sum, and we do some joining from the purchases and products because it's all going to rely from data on the purchases table and the for which details the revenue and the products information. And the next functionality is to list clients that have gmail.com email addresses. So this is where we use like our regular expressions operator in SQL to find records for an email that have the gmail.com ending, and we order them by client's name. The, just this, we reach our final 2 functionalities, which is just to retrieve the most popular products based on purchase counts. So we use another aggregate function, counts, to do so, and we also join the purchases with um, the products table, and purchases table, to do that. And we list the product's name and development team name for products costing more than 5,000. So then we just want to just select the distinct product name, team names to avoid redundancies, because I just focusing on specific products and team names. We will also need an inner join to link the product and dev team tables together to get our information. So now that you're done with all the functionalities, we have just decided to create views for our database where, as we learned in class, are just conceptual, the external views of the database that um, that hide unnecessary data. That's the plan for audience that need to know. So, for example, for the clients table, it just creates a view of the clients table. This is just for clients to look at. You don't need to know the dev team, the product who is making what and such. So from there, we create a view of the dev team, products, and feedback.